two. Okay. Oh, Cass, grab one of each. Okay. Okay. Now, guys, here's the deal. I need the whole period. I hate to tell you that, but that's good because tomorrow I don't need the whole period. I don't have to teach you anything tomorrow. I'm just going to kind of wrap it up again. I'm giving you a worksheet today on z-scores. And then tomorrow, another worksheet on z-scores. So if you really get it today, tomorrow's so simple. But if you're confused, then you come in tomorrow, you ask me questions, we answer them, and then we get you going on the next worksheet. So it's like a double dose, but the notes are all going to be in your lap today. Okay, so, are you ready? Stay ready.
Ready.
All right, that's all I need to hear. Okay. All right. Okay, here we go. I understand when I say some of this stuff, you're going, I don't even know what you're talking about, but I'm going to read it anyways. Here's what you can do when the lesson's over. You should be able to describe what is a z-score. What's a z-score? Okay? You should be able to actually calculate the z-score. This is really easy. This is a formula. I'll give it to you on page 345. Okay? This is going to be use z-scores to do what?
Describe the percentiles.
The percentiles of the data. And I'll tell you what percentiles are in just a little bit. Maybe you already know, okay? So these three things, when we're done, when you walk out the door, go back and read these three and go, yep, or if you say no to any of them, well, we have tomorrow to wrap it up. Okay, so looking at this chart, can we just look at one of these? I'm just going to look at this one. This is a normal distribution right there. Okay. There's actually three of them here, but let's just look at one. Okay. Just by looking at this normal distribution, can you guys tell me the average?
13.
Yeah, it looks. I mean, it's supposed to be in the middle. Mine's off a little bit, but yeah, you're right. The average is what? 13. Can you tell me what you think the standard deviation is? Up one, back one. What is it? Standard deviation is what?
1.
1? Agree? Okay. And if I said you go 1 standard deviation, what number correlates to 1 standard deviation?
14.
14. The reason you didn't say 12 is because I said what?
Those.
1 standard deviation. I didn't say -1. So -1 is which way? Backwards. +1 is forward. Okay. So if I said, okay, what number correlates to 2 standard deviations? You'd say
50.
15. 1, 2, right? Okay. What would you say if I said what number correlates to 1.5 standard deviations? Okay. 1.5 would be about right. There's one. Right there. What are you saying?
Half.
A half?
14.5.
Oh, 14 and a half. Yeah. Yeah, you know, so you guys, every time I ask you 1 there, 2 there, 1.5 there, when I give you those numbers, 1, 2, 1.5, that's a z-score. Your z-score is basically how many standard deviations you fall from the average, this way or this way. Okay? So if I said today, you have a z-score of -2.2. Does that mean anything to you right now at this point?
Yes.
Where are you at? Start me right here. Here's the average. Where am I going?
Back to.
Backwards, 1, standard deviation 2, and how much more?
0.2.
Maybe just a little bit. So it would kind of, there it is. That's actually your score. I don't know what it is, 10 point something. Yeah.
Are we gonna have to find out how far to go back?
Yeah, your job is to figure this out.
No,
I'm giving it to you right now, but that's what a z-score
like
is.
when we get to like when you get 2.2 and you go back 2, are we gonna have to figure out how far back is 0.2?
No. You don't, just be patient. You'll see. I'll show you what we're gonna do in just a second. I just want you to understand what a z-score is. It's just a number that tells you to go either backwards or forward. How many standard deviations? Well, in this case, 2.2 backwards. Yes, Brady.
Is this gonna have to deal with like linear equations because there's like x and then there's y.
No.
Z.
Nope. Don't worry about that. Okay. Next slide. This is just a quick slide. I want to tell you something about where data comes from. We'll use this more on Friday, but for right now, I just want to throw something at you. Okay, here's the deal. When you take data, you talk about the population of whatever we're talking about, and then you talk about a sample of the population. So here's the deal. If I said, let's get the height, the average height of a student at Central High School. Okay, what's the real population we're talking about? How many people do you think are in the real population?
200.
How many?
1,300.
1,300 students at Central. You're a little high. It's more like 900 to 1,000. So the population is a big group of people I'm talking about. Now, a sample would be just a smaller group of that population. So would you agree your classroom would be a sample?
Mhm.
Yeah. Is it a big sample? Like if we had 900 some people and I took your classroom as a sample and there's 20 of you, is that a real big sample? Not really, no. But it's a sample. Okay, so here's what happens in statistics. You will get an average. You will get an average for the population. They call it mu. Another Greek letter, mu. Okay, the sample population is just that. So you guys, the terminology, the letters I've been using with you, sometimes this goes with the sample. This is the average of the sample. This Greek letter, mu, is the actual population, or the actual average of the population.
What does it stand for?
This one,
Yeah.
it stands for mean. These both stand for mean. This letter with the bar above it, that's the mean of the sample. Your classroom would have an average. But the real average of the whole school would be this Greek letter mu.
To me, it reminds me of like two sharks.
Okay. And Brady, to me, it reminds me of the waves in the water, okay? All right. Standard deviation. How do we represent standard deviation with the real population? With sigma. Sigma is the true representation of standard deviation for the population. When it comes to the sample, they just go with the letter S. Okay? Why am I telling you this? Because some of you juniors might end up in statistics next year. And I just want you to know right now, there is a difference. This is the average of the population. This is the average of the sample. This is the standard deviation of the population. S, standard deviation of the sample. There's nothing to this slide other than I wanted you to hear it before any of you go that way. Yes, sir.
They're saying you can find the population and the average and sample, and you can find the standard deviation of both.
Yep, you can.
All different.
It will be different, yeah.
Yeah.
Yeah, like your classroom, the average height in here might be 5'7", but the real population, the whole school, it might be 5'4" or 5'9". I don't know. So our sample would be close to the average. You would think, right? I mean,
Maybe.
I think we have all kinds of heights in here. Okay, so what is a z-score? Tate, you probably already know what a z-score is because I've already explained it to you.
Yeah.
Okay, here's what I wrote. You can write it in your own words if you don't like my definition, but all right, here it goes. A z-score is how many standard deviations a data value is from the what?
Mean.
The mean. There you go. So, basically, if I'm going to talk about z-scores, you should know what z-scores are. A z-score is a number. It tells you how many standard deviations a data value is from the mean.
Also, is this like absolute value?
No. No, because z-scores can be positive, z-scores can be negative.
Yeah, but it's like how many numbers it is away from 0, yeah?
Yeah, it is. It's not the distance, it's actually, the number means go left if it's negative, go right if it's positive. Okay. You know what? I'd like you to do this, 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 this. Just cross that out. We don't need it. Now, what they're trying to point out here is something like this. A z-score falls under the normal distribution curve. What they call the average, they call the average just a simple number. Let's just call it 0. 0 is the average. Okay. So a z-score is just going to be positive. If it's positive, it's to the right. If it's negative, it's to the left. So a z-score could be right here. Right there could be your z-score. Let's just make this up. I'm going to say you have a z-score of 0.34 right there. Okay. Now, exactly what does that mean to you? Do you have any idea right now? I heard. Somebody say it.
It's the
How many standard deviations?
Like 3, 4.
I'm only 0.34. So from there to there is, that's really close to 1/3, isn't it? So I'm like 1/3 of 1 standard deviation away. Okay? Now, here's the deal. That z-score actually translates to a percentage. Now, do you guys know anything about this? Percentiles. If I asked you right now, if you took a huge test, a big test, and you scored it in the 10th percentile, do you know what that means about you? Does that mean you did very, very good or very, very bad? Which one?
Average.
Yeah, it's not average.
Very
It's either
bad.
good or it's very bad.
good. Very good.
Very good.
Very bad.
Very bad.
Yeah.
Okay, here's what it means. 10%. If you're in the 10th percentile, it basically means this. It means 10% scored, and I'm talking about a test. I always talk about a test because it's easy to relate to. It means 10% scored below you. So, now tell me, is that good or bad?
It's average.
Yeah, that's not average.
Could
10%
be.
scored below you.
Yeah.
10 out of 100.
Oh.
10 people out of 100 scored below you. That means what scored better than you?
90.
90 scored better than you. Do you want to be in the 10th percentile? No. No.
Depends on how many.
What if it was?
Okay.
What if they were all like together?
Yeah.
Like it's like 100 out of 100, and you got like a 91, but everyone ahead of you got like.
Then you will be 91 on the test doesn't mean you're in the 91st percentile. You
Yeah,
could
no,
get-
I know.
Okay.
But that doesn't necessarily mean it's a bad thing. You just didn't do as well.
Well, you know what it is? It's just a comparison of how you compare to everybody in the group.
Yeah.
So 10% means you scored better than 10% of the people in your group. That's what it means. It doesn't tell you your score. It just tells you what you did better than. 80% means 80% scored what?
Worse
Below you. Okay, I'm just trying to get you some info on what it really means. And that is what a z-score is going to tell you. Okay? Now, you see that z-score over there of 0.34? I want to know how well you did compared to everybody that took the test. Okay? Well, you guys should all know this. If you guys were if this was one standard deviation out there, okay, the average is 50%. So right here, guys, 50% are below you. If you were at 1, what do you guys know about 1? What percent fall between the average and 1?
34.
34. Plus the 50. You scored better than what? 84% of the population. Okay, well guess what? You didn't score 1 for a z-score. You had a 0.34 for a z-score. So you guys, you scored better than these people. These people you scored better than, to the left of the line. Well, how am I going to know what percent that is? I'm going to use my z-chart. So let's figure out how to do this. How do you use a z-chart? Well, since I said 0.34, you got to look at right here. Here's your 0.3. Are you guys looking on your yellow sheet of paper? Okay, look at your positive side. The positive side will be to the right of the average. It has a picture on the top. The negative side will be to the left of the average. There's two sides. So you guys look for 0.3, then you look for point what? Not 3.4. 0.04. If you add 0.3 to 0.04, you get 0.34. So what correlates to that, or what does that come down to? Right here. Is that what you're getting? So your z-score of 0.34 equates to what percent?
Wait, hold up, how do you know it's 0.34?
Oh, I made that up, Brady. Brady, I just made that up. I said, let's pretend this is 0.34. Let's pretend. Okay? Now that I'm pretending, I just want to know what that equates to. Here's 0.3, here's 0.04, it's right here. Now what percent is this number 0.6331?
3.3%.
Okay, now, here's the deal. That's a point here. You have a z-score of 0.34. Here's what it means. It means you scored better than what?
63.21%.
Yeah, 63% of the people that took the test, you are scoring higher than them. That would be all these people, right? You okay with that? Okay, can I ask you this question? Who scored better than you? These people scored better. What percent scored better?
37.
Yeah, but how are you getting that?
Take 62.31 out of 100.
Okay, so you're saying the entire population is 100%,
Yeah.
and you're saying take away the people that I scored better than, 63 what?
0.31.
0.31%. And if I do my subtraction, I'm going to get 36.69?
Yeah.
Okay, so I scored better. No, I didn't. I'm sorry.
Worse.
I scored worse than that percent. So what percent scored better than me? 36.69. What percent did I score better than? 63.31. Okay. The second you know you're to the right of the average, you know you scored over 50, better than 50%. If you're back here, guys, this is never good when we talk about, if we're talking about standardized testing, that's never good to fall over here. Okay? Do you have a feel for what we're doing?
Is that higher than average?
What's that?
That's higher than average.
Yeah, anything above 0, any z-score above 0, you scored better than average. Any z-score negative z-score, you scored below average. Okay?
But there was people that scored
Yeah, there's people that.
below average,
Oh, what is average? It's the middle.
50%.
Half people did better than average. Half people did less than average. It's just a divider. Okay?
So, if you get exactly 50% your average,
If your z-score is 0, guess what? You scored better than what?
Better than
50%. A z-score of 0 means you did better than 50% of the people.
Yeah, but is it really like realistic? 'Cause I feel
Yeah,
like
it is. Brady, they use this all the time. You'll see as we go.
Using the doctor's office.
Okay.
yeah,
Okay. Just a quick tell you how z-scores kind of came about. Okay, z-scores are kind of like this. They're just like normal distribution. You guys, you usually put the average right here, don't we? Well, the average, they didn't want to put a number down. They just said this. Let's just put 0. So if you did the average on a test, your z-score is 0. Then they said, well, let's just kind of go with a z-score of 1. Just means you're 1 standard deviation to the right. Okay? Z-score 2 means what?
You scored 2.
2 to the right. Z-score 3. 3 standard deviations to the right. And then same back here, right? This isn't going to change. This would be z-score of what?
Negative 1.
Negative 1,
Negative 2.
negative 2,
Negative 3.
negative 3. Okay. Can you guys do this for me? Can you tell me, following this rule, 68, 95, and 99.7. Okay, following that rule, which is what you were tested on yesterday, can you tell me if your z-score is, let's do a 2. If you have a 2 for a z-score, tell me what you did better than. What percentile did you just fall in? Remember, this is what percent. What percent fall in this column?
34.
34.
34%. What about this one?
13. Yeah.
13.5. Okay. Does that tell you already that if that's your Z-score, you just did better than what percent of the people? 90, would you say 97 and a half? You're right. So really, this would, a 2 should equate to what? 97.5%. But I got bad news to tell you. That's not quite right. That rule was given to you to make the calculations easy for you, because a 68, you cut it in half, 34, 34. This is not right. This is an approximation. So if you're using this rule, you're really close, but you're not exact. So how do we get exact? We use the Z-table. So the Z-table that I had you use just a second ago, this is how you get the exact answer. So a Z-score of 2, would you please look it up for me? It's going to be around 97.5. I don't have it in my hand, so I need you.
37 or 0.9772.
0.9 what?
772.
772, which is exactly what percent did you do better than?
97.72.
Percent. So is it close? Yeah, that rule I gave you a couple days ago, that's really, really close to the right answer. But the exact answer is using what? Your Z-tables will give you what kind of answers? Exact. So if we really, really want the exact answer, we use our Z chart, okay? I was just trying to throw that at you just so you understood that. Okay? All right, the fun starts now. You ready? How much data lies below a Z-score of 1? Watch this. Here's what I would do if I were you. I know this is the average. Where's a Z-score of 1, guys? About. To the right or left?
Right.
That's positive 1.
Oh, okay. Right.
Aren't you here? Okay, that's 1. So you have a Z-score of 1. How much data lies below it? I want, here's what I want. I want what percent did I do better than? Well, let's look it up.
84.1.
A Z-score of 1 means, are you looking it up? What do you call it? 8413. Okay, 8413 is what Carr says. Are you guys agreeing with him? Yes or no? Guys, you gotta look it up. Yes or no?
Yep.
Yeah. Okay, so that would tell me what falls below 1 standard deviation. 84.13 falls where?
Below.
Below. Okay. Period. That's all it is. They say how much data lies below the Z-score of 1? 84.13%. Sorry, forgot my percent. Okay. All right, guys, do a Z-score of what this time?
2.8.
Yeah, is yours negative?
Yeah.
Can you guys do a positive? Because this is positive. That's a positive. Yours is negative, make it positive, okay? So if you have a Z-score of 2.8, well, by the way, I always think this helps. Maybe you guys are thinking, he's crazy. We don't need to do this. Here's a 1, here's a 2, here's a 3. So where's a 2.8? Closer to what?
3.
Closer to 3. There. You know what I want? I want this. How much data falls below a 2.8? I think you can tell it's a lot, right? It's a big number. Okay. So what does 2.8 convert to? Using your table? Tate, what'd you get? 99 what? 74. Okay, 9974, which calculates to what percentage?
99.74%.
Yep. Falls where?
Below.
Falls below. Which means if we were talking test scores and you have a Z-score of 2.8, did you do really well on the test?
Yeah.
Yeah, you did extremely well. You beat 99.74% of the population.
How many people were taking
Well, that's a good question. What if there's only 5 people or 6 people taking it? You
That's
didn't-
awfully specific.
Yeah. Here's the deal. Most of the time, it's a lot of people we're talking. Maybe 5,000 people took the test. You know what I mean?
Yeah.
Okay. How much data lies what? Careful. Above is different than below, obviously. Do it. See what you get. This time your z-score is negative. Be careful. Guys, I tried to draw it. It's hard to draw in these little spaces. Here's -1 deviation. Here's -2 deviations. -1.47 is somewhere around here. But I want what falls where? Above. You know what I want? I want this side. The problem is my table only gives me what?
Below.
Below. Okay, so what does this translate to? Point what?
7 or 0.07.
0.07 what?
0.08.
08, which means 7.08 percentage. Scored below me. Brady, your hand was up, I'm sorry.
Well, I guess you could
Finish it?
just subtract that by 100.
Right. Okay, so now here's the deal. I know I only beat 7% of the people, but that's not what it said. It says how many people finished above me. Well, now you got to take the entire population, 100%, take away what?
7.08.
7.08%. You end up with what percent? 90 what?
92.
92.92% scored better than me. Almost 93%. You okay? Do you guys like this stuff? Do you like to make a little picture so you know what you're talking about? I do, and I will do this. You don't have to. I'm not making you, but I'm visual, and if I'm visual, I make pictures. Okay? All right. How much data lies where?
Above.
Above a z-score of?
2.66.
2.66. Here you go. Z-score 2.66 equates to what? And by the way, here's my picture. Here's 0. Here's 1. Here's 2. Here's 3. And we want what? We want 2.66 right here. Right there. So we want to go above that. So we want this percent of the people. By the way, that's a small percentage of the people that scored above my score. What does this equate to?
0.9961.
0.9961? Okay. You know, I hear car talking. Are you guys agreeing? Yeah? Okay. Which is 99 point what? 61%. I scored better than just about everybody. What scored better than me though?
0.39.
100%, take away that percent. What'd you say it was? 0.39%? Okay, so a very, very, very tiny portion of the population scores better than me. This would be like, maybe 1,000 people take the test, 1 person beats me. You know what I mean? Good? Okay. That is just calculating what a z-score, equates to when it comes to percentages, percentiles. Now,
To calculate it if you're the best,
if what?
if you're the absolute best.
If you're the absolute best, I'm sure your score. What does the table go up to, can I ask? Does it ever hit 100%? I don't know if it can. I don't know. I gotta look that one up, Brady. Z-scores. Okay, hey, guys, I've been giving you the z-score. Now you gotta come up with the z-score, and here's how you do it. It's a quick formula, so how do we get the z-score? The formula says take x. By the way, x is your data. I'll just write that. Your data. Now, if you guys were taking a test, you would take your test score and put it right there. Then you subtract mu. What's mu?
The two shark things.
The two shark things, okay. Mu is simply the average of the population. Okay. And then divided by what?
Yeah.
Say it.
Sigma.
Sigma with standard deviation. Okay, so this is really simple. You take whatever your score is, x, take away the average test score, and divide by standard deviation. Let's do these two. Calculating a z-score. In a given population, the data is normally distributed over the mean of what? 35. So if the mean is 35, that means mu is 35. And the standard deviation is what? 2.8. So guys, they're giving you this, they're giving you this, and now what did you score? That's x. You scored what on the test? 42. So what's your z-score? Well, you got 42 on the test. You subtract the average 35, divide by the standard deviation. Tell me. Your z-score is 2.5? Okay. 2.5. Is that good or bad?
It's, no, it's good. Yeah.
Hey guys, one standard deviation better than the average, that's 34% better than the average. Two standard deviations is another 13.5%. You're already up to what? 34 plus 13 is 47.5. Guys, you're already up to 97.5% better. You're at half. Oh my gosh, you're almost the best. This is a great score. Great score. Now, do I want the percentage you did better than? No, I just wanted you to do what? Just give me a z-score. If you get a 42 on a test and the average is 35, that's your z-score. Next, do 32. Does it say 11?
Yeah.
Get rid of 11. 11 doesn't even make sense. Do a 32. Is it okay if I do this, guys? If I go, what's the z-score of getting a 42, 2.5? What's the z-score of getting a 30, getting a 32 on my test? And you'll tell me in a second, won't you? Jaden, what'd you get? You got what?
Haven't gotten it yet.
Yeah, you have. You have. You're staring right at it. Roshan, what'd you get?
Yeah, negative 1.07.
Okay, negative 1 point what? 0.7. There's no reason to keep going because your z chart only goes up to the hundredths. Quit right there. Don't write them all up. Just quit right there. Oh, by the way, this person did one standard deviation worse than the average and a little bit more. So you could go right now 50%. Take away what? 34. You're already down to what? 16. And a little more, you're probably down around 14%. You only did better than 14% of the population. I mean, I can estimate in my head where you did just by looking at those numbers. Can you? Can you do it? Because that's important. If you can do that, you really, really do get this. All right. Now the fun really begins. Here comes the story problems. This is what your homework looks like. Bryce. Can you do this, please?
Yeah.
Okay, thanks. All right. This is what your homework looks like, so pay attention right now because we're going to do a lot of work. Here it goes. Okay, homework. Calculating a z-scores. In a given population, the weights of newborns are normally distributed about the mean. The mean is what? 3,250 grams. That's what a newborn baby weighs. Okay, the standard deviation of the population is 500, not kilograms, just grams. Okay, so they gave you this. The average is 3250, and the standard deviation is 500.
500 kilos.
No. I said grams. Okay.
Big baby.
Yeah, it would be a big baby. You're right. All right, but don't talk about yourself. All right, here we go. What is the Z-score of a newborn weighing 2,500 grams? What percent of babies are beneath that baby? Okay, so you have a baby that weighs what? 2,500 grams. What's the Z-score for a 2,500 gram baby? Calculate, do it yourself. That's what you're doing, right? Take your data, 2,500 gram baby, take away the average, divide by standard deviation. Your answer was?
Negative 1.5.
Negative 1.5 exactly? Okay, so to me, if I'm looking at a little distribution chart, it kind of looks like this. Here's the average, okay? And we're saying this is 1, this is 2. 1.5 is right about here. Okay, what am I looking for? What percent of them fall where? Beneath that baby's weight. So where am I looking? To the left or to the right?
Left.
Left. I want this percent right here. Well, what does that Z-chart table do for you? It gives you everything to the left of that number. What does this calculate to, guys?
0.668.
668, okay. Which translates to what percent?
6.68.
6.68% weigh, what do they weigh? Would you say less? Okay. 6.68% weigh less than that baby that we just came up. Now this baby, that is tiny. That's a tiny baby. 6% weigh less than that baby. Okay?
That time.
What? It's not that light? Let's not try to get into that. I don't know. I don't even know what that weight is, to be honest. Okay, go up.
It's like a solid.
Okay. Let's do this baby. This baby weighs what? This newborn weighs what?
4,500.
4,500. What percent of the babies are not below, but what? Above. I want to know what percent of the babies weigh more than that baby right there. Calculate the Z-score. Z-score of a 4,500 gram baby. Baby's weight minus the average divided by sigma, standard deviation. Bryce, what'd you get?
I don't have a calculator.
Ethan, what'd you get?
2.5.
Ethan gets 2.5. Would you guys agree or disagree?
Agree.
I got an agree. Everybody? Thumbs up? Good. Here's the deal. Look. Here's your little chart again. Here's the average. Here's 1 standard deviation. Here's 2 standard deviation. Here's 3. We're at what? 2.5. We want to know what weighs above. So we're looking for this percent right here. You guys, this is us. We're looking for this. Now the table's not going to give you above. It gives you below the Z-score. So what percent does this translate to?
99.38%.
Louder.
99.38%.
99.38%. Okay. So that's what falls below that baby. So what weighs more than that baby?
62%.
Yeah, aren't we going to take 100%, take away the 99.38? And get what? 0.62. Okay. 0.62 weigh more. There, way more. Not much. That is a big baby. And that big baby, there's not much more that will come out bigger, I guess. Okay. Okay, you ready? I'm not doing that last one. I'll give you the answer, but I'm not gonna do it. I wanna do this one. Oh, you know what? You know what? I have more room down there. I'm not gonna do this one. I'll give you the answer to it. I'm gonna do the next one. Okay, here we go. Okay. Ready? What is the probability that a newborn baby weighs between 3,000 grams and 3,650 grams? Use what? Z-scores to determine this. Well, let's go get Z-scores right away. What's the Z-score on a 3,000 gram baby? What's the Z-score on a 3,650 baby? Can you guys take over and get those answers?
You should do 2 of these.
No, you'll see it's not that bad of a problem. It's actually pretty easy.
Nobody gets the Z-scores.
Well, the Z-scores are pretty straightforward. Anybody get the Z-score for the 3,000 gram baby?
Negative half,
Negative what?
negative 0.5.
Negative 0.5. Okay. Anybody get the Z-score for the bigger baby?
About 3%.
Dot 8 maybe.
It's what?
0.8.
0.8. Gotcha. Okay. All right. Now here's the deal. You guys, you want the probability that a newborn baby weighs where? Between that baby and that baby. Well, Z-scores, when you think about it, if that's the average, a negative 0.5 would be over here somewhere, and a positive 0.8 would be right here somewhere. Okay? Well, here's the deal. You want to land where?
Between
You want a baby, what's the chance you get a baby between there and there? Wouldn't it be nice if you knew the percentages? What does a 0.8 convert to? Use your table.
78, 81.
7881. Okay. What does a negative 0.5 convert to?
3085.
3085. Okay. So here's what happens. This is 78 what? 81. This is 30.85. Now that's to the left of this line. You don't want left, you want in between. So what percent falls in here? How are you going to get it?
Subtract your higher one.
Yeah, take your highest percent. Everything to the left of that line is 78. Now subtract off this piece. This piece is right there. So it's that minus that, right? Subtract and you get your answer. Okay, I don't know, you probably already did it. 7881 minus 3085 gives you what percent?
4796.
4796 is correct. Okay. So what's the chance you find a baby between 3,000 and 3,650? Right there. That's the percent. The one above it, guys, is the same problem. If you want to do it later, here's the answer. Hey, you want to do it later? Try get 95. That's the answer. Okay? All right. Okay, let's try to get this one going. And I know the clock's going to ring in 3 minutes, but it's the same problem. I just need to tell you right now, we're going to compare an ACT test score to an SAT test score. Morgan took an ACT test and an SAT test her junior year. The ACT test has an average score of 21. The standard deviation is 2.4. The SAT has an average score of 1010. Standard deviation of 218. Morgan got what on her ACT test? 26. So here's what I would do if I were you. Calculate the Z-score for her ACT, which would be 26 minus the average. Her average was 21. Standard deviation, 2.4. Then I do the SAT. She got what on the SAT? 1250. 1250. Take away the average. 1010. Standard deviation 218. Z-scores are, guys listen please, 2.08, and the other one is 1.1. And I'm kind of giving these answers just because the bell's going to ring. But I've got to show you this. Watch what happens. This converts to, well, I'll just do this, 98.12%. This one converts to 86.43%. Here's my question. Which test did she do better on? The ACT. Because she did better than what percent of the population? You know what? She's in the top 2%. Top 2% with that score of a 26. She's in the top 15% here with that score. So the answer to this question is she did better on the ACT test. Okay, guess what? Here's your assignment. I did all the teaching today. So you should have to listen to me well. Okay, how'd it go? Did you guys feel like you understood it?
I understood it.
You understood it?
Yep.
Okay. Maddie, should I even ask you? Okay. Sydney? Yes? Okay, good.